Welcome back, dear students. Let's continue with exercise 13b today. So, we have the first question for the day, question number 10, which says diagonals of rhombus ABCD intersect each other at a point O. We need to prove this. Now, what is rhombus? Rhombus is a parallelogram where all the sides of that particular parallelogram is equal to each other. Okay, so all of you are quite familiar with rhombus. So this is the shape of a rhombus. Okay, so see, if you see here, A, B, B, C, C, D and AD, all of them are equal to each other. So they are equal to each other. This thing is what you need to keep in mind. Okay, and if you look at A, B, C, D, this is also a parallelogram. Simple. Now, question is saying that the diagonals. So see here. So BC and AC are the diagonals. So they intersect at point O. Okay, so they intersect each other at point O. Okay, now we need to prove this particular thing. So let's see how to prove this. So one thing that you need to keep in mind is the diagonals of a rhombus are always perpendicular to each other. Okay, so it will be perpendicular, and one more thing that you need to keep in mind is this and this. Okay, so they are also going to be equal. Similarly, this one and this one, they are also going to be equal. That is, OB and OD will be equal and OA will be equals to OC. That's what you need to keep in mind. Now, one more thing, if this is perpendicular, if this is 90, this is also going to be 90, this is also going to be 90, and this is also going to be 90 degree. So these are things that you need to keep in mind. Okay, now in quadrilateral ABCD, AOD is equal to COD, which is 90 degree. As I said, AOD and COD both are going to be 90 degree each, as I told you. So in triangle AOD, okay, in this triangle, if I see, this is 90 degrees, so side opposite to this, that is AD, becomes your hypotenuse. So if you apply Pythagoras theorem out here, you get AD square equals to OA square plus OD square. Okay, so that's what you are going to get. Now from here we will calculate what is OA square, because see, in the left hand side we have OA square, isn't it? So let's calculate what is OA square. So OA square will be AD square minus OD square. Let me call this as equation number 1. Okay, now next thing that I want is OC. Okay, so for that, what am I going to do is I'll make use of this triangle. Okay, so in triangle COD, if this is 90, then opposite to this, that is CD, becomes your hypotenuse. So that's why you get CD square is equals to OC square plus OD square using Pythagoras theorem. But my aim is to find OC, isn't it? So from here, OC square will turn out to be CD square minus OD square. Call this as equation number 2. So obviously, since there is a plus sign, we need to add equation 1 and 2. So when you add, so when you add, in the left hand side you have this one. So this becomes OA square is AD square minus OD square plus OC square is CD square minus OD square. Okay, now see, OD square minus OD square minus OD square gives you minus 2OD square, isn't it? Now, as I told you, OD is nothing but half of BC, isn't it? So since OD is half of BC, now in place of half of BD, I'm sorry. So in place of OD, I can write BD by 2. So in place of OD, I have written BD by 2. And one more thing is AD and CD, So AD and CD are also equal, as I told you in the beginning. So that's why in place of the CD, I have written AD. Okay, now open the bracket. Okay, so when you open the bracket, it becomes BD square by 4. But this 2 and 4 gets cancelled. So that's why you will have only 2 in the denominator, and AD square plus AD square gives you 2 times AD square. And that's what we want to show here, isn't it? So this is my right hand side. Pause the video and note down your solution. Let's look at next question. So in an isosceles triangle ABC, AB is given to be equals to AC and D is the midpoint of BC produced. Now what is the meaning of this? Let's try to understand. Okay, so there is triangle ABC. Okay, now when you produce BC, so produce means extend. So when you extend this BC, line BC, okay, then D is a point on the BC. Okay, so when you produce this line BC, then in the extended line D is a point. That's what is the question saying. Okay, now what we need to prove is, we need to prove that AD square is equals to AC square plus BD into CD. Okay, so in isosceles triangle ABC, you see AB is given to be equals to AC and D is a point on the produced line BC. Okay, now what am I doing is, see in the diagram you see that this thing is extra. So I have constructed a perpendicular AE which is perpendicular on BC. Okay, so in triangle AED, so if you see here, triangle AED, AD acts like hypotenuse because this is 90 degree. So that's why using Pythagoras theorem you get AD square is equals to A square plus ED square. Okay, so from here, see here ED, so this ED can be written as EC plus CD. Look at this, ED is this entire line which can be written as EC plus CD. So that's what is written out here, and let me call this to be equation number 1. All right, now similarly in triangle AEC, okay, so if you observe triangle AEC, this triangle AC acts like hypotenuse, so that's why you have AC square is equals to AE square plus EC square. Okay, now from here what is AE? What is AE square? AE square turns out to be, bring this out here, you get AC square minus EC square. So call this as equation number 2. Okay, now putting the value of AE square in equation 1, in place of this, what will I write? I will write this one. So let's see how much do we get. We get this much. Now let's expand this. So this is in the form of A plus B whole square, which is A square plus B square plus 2AB. Okay, now what thing that you see here is these two gets cancelled. Okay, and among this one, these two, CD is common. So when you take CD common, so from CD square, CD is left, plus from this one, if CD goes, you have 2EC left. Okay, now 2EC plus CD is equals to BD. Let's see whether it is true or not. 2 times EC. Now this one and this one, they will be equal when you drop a perpendicular. That thing you need to keep in mind. So that means BC can be written as 2 times EC, isn't it? Double of EC. This BC is double of EC. And if you add BC, you know that BD can be written as, this BD can be written as BC plus, from here to here is CD, but BC is how much? BC is 2 times EC. So 2 times EC plus CD is nothing but BD, isn't it? So that's why in place of this, what am I going to write? I am going to write BD. Okay, so you get BD into CD or CD into BD, both means the same, and that's what I want to show here, isn't it? So this is how we need to prove this particular problem. Pause the video and note down your solution. Let's move to next question. So question says, in triangle ABC, angle A is given to be 90 degrees, CA is equals to be AB. Okay, CA is equals to AB. So see here carefully, CA, that is this one, is equals to AB. Okay, and D is a point on AB produced. So again, if you produce AB, if you extend AB, then D is a point on the extended line AB. Okay, now we need to prove this quantity. So it's similar one. So in triangle ACD, okay, so first and foremost, in triangle ACD, CD acts like hypotenuse. So we have CD square is equals to AC square plus AD square. And you know AD can be written as, this line can be written as AB plus BD. So that's what is written out here. Okay, now let's apply A plus B whole square formula. You get A square plus B square plus 2AB. Now you know that AB and AC, they are equal, isn't it? So that's why, see, first and foremost, what I have done here is, let me take it out here, so it becomes a minus BD square, okay, and in place of, you know, AC square, I have written AB square, because you know that AB is equals to AC, okay. So we have AB square plus 2AB, now BD, you know, so this BD is this much. So can I write this BD as AD minus AB, right? So that's what is written here. So BD is AD minus AB. Now let's open the bracket. So we have in the left hand side CD square minus BD square is equals to, here it is AB square plus AB square 2AB. Now see here, just open the bracket, 2AB into AD is 2AB AD minus, okay, plus into minus is minus, 2AB into AB is 2AB square, okay. Now in fact what you can do is AB square plus AB square is just 2AB square, isn't it? So instead of writing this, you can write 2AB square here, okay. Now what you see here is, here also 2AB square is there, here also 2AB square is there, they will get cancelled, okay. So ultimately what is left? We are left with 2AB dot 2AB into AD, right? So that's what we wanted to show here. CD square or DC square, both means the same, okay. So minus BD square is equals to this much. That's what we wanted to prove here, okay. So you may pause the video and note down your solution. Alright, so next problem. So in triangle ABC, AB is equals to AC and BD is perpendicular to AC. Prove this. So see here carefully. So it is given that AB is equals to AC, okay. So AB is equals to AC, okay. So remember this one, they are talking about this one. So these two are equal. Now it is said that BD is perpendicular to AC. So BD is perpendicular to AC. You need to prove this. So in triangle ADB, so in triangle ADB, this is 90 degrees. So that's why this is going to be your hypotenuse. So AB square is going to be BD square plus AD square. That's what is written out here, okay. And let's find AD square from here, okay. So from here AD square will be AB square minus BD square, and let me call this to be equation number 1. Simple. Now all of you know AC, see here carefully, AC, this entire thing is nothing but AD plus DC. So since AC is AD plus DC, can I write AC square as AD plus DC whole square if you squaring both sides, okay. So if you square both sides, you can write squaring both side also here. So when you square both side, you get this much. Now apply A plus B whole square formula, you get A square plus B square plus 2AB, isn't it? Now what am I doing is, in place of this, you know, AD square, in place of AD square I am going to write this much. So using 1, AD square can be written as AB square minus BD square, and the rest are written as it is, okay. Now all of you know again that AB is equals to AC, okay. So in place of AB, I have written AC, okay. So AC square minus BD square, and rest are same. Now see here, in the left hand side we have AC square, here also we have AC square, they gets cancelled. Simple. Now bring these two to the right hand side, you get this much, isn't it? And that's what we are expected to prove, isn't it? 2 times CD or DC, whatever you say, into AD. That's what we need to prove, okay. So you may pause the video and note down your solution. So with this we close this particular exercise on Pythagoras theorem. So there are many sums where hints are given to you in the exercise. So try the sums where hints are given, okay. Thank you very much.